In this video, we're going to be taking a look at 3 different simple machines and their mechanical advantage. First, we're going to take a look at a common simple machine, the pulley. And in this pulley over here, we have an object that's hanging from a rope, and the rope goes over the pulley, and then you pull downwards to get this pulley to pull this object upwards. Now, what a pulley does is it just redirects the force, assuming that it's frictionless and massless. It is the same amount of tension everywhere along that rope. So if you pull down with a certain input, then you're going to get a certain output over here. And that output is going to be 20 newtons. So in this case, we're not getting any mechanical advantage. We put 20 newtons in, and then we get 20 newtons out. Now, if you use a system of pulleys such as this, and then you attach something over here, you can get a certain mechanical advantage. Now, remember, what a pulley does is it redirects the force, but you still have the same amount of force of tension in the rope. So if we have 20 newtons over here, then on the opposite end of the pulley, we have 20 newtons, which carries down over here, and you come around here, this still has 20 newtons, and then it goes around here, 20 newtons, and then around here, 20 newtons. Okay, so we have 20 newtons all across. So if we take a look across this horizontal sight line, then we have 1, 2, 3, 4 points of contact. So we're going to have 80 newtons of force. 80 newtons of force output. So if we do the force output divided by the force input, we have a mechanical advantage of 4, which is good because then we have quadruple of force that we put in outputted by the system. Now for our next one, we're going to take a look at a lever. And over here, what you're doing is you're increasing your torque by increasing your lever arm, which is the distance from the fulcrum to where you're applying the force. So because torque equals force times R, which is your lever arm, the torque on this side is the force that you put in times your lever arm. And then on the opposite end, you get a certain force output along with that lever arm. Now, if you take a look at your force output, if we just do a little bit of algebra here, we divide both sides by 2, then your force output is equal to your force input times 2. So, and then in this case, our mechanical advantage equals 2. You have double the force output that you do for your force input by increasing that lever arm on the side that you're putting in the force, and then decreasing the lever arm on the opposite end, and then in turn you get more force pushed out. Now, taking a look at the last one, we have an inclined plane, and the way to look at this is a few different ways. So I'm going to work out the short ways and the long ways. So what you can do is, if you're pushing an object, we'll say a 2 kilogram object, up this ramp, you're getting a little bit more force output by the system, because if you're pushing up the ramp, you're using much less force as opposed to the force of just going straight up against the force of gravity. Now, the easiest way to solve this would just be taking this length and this height and actually just dividing them. 4.5 divided by 3 equals 1.5. That's actually your mechanical advantage already. So that's a quick and easy way to get your mechanical advantage. The second way is taking 1 divided by the sine of the angle, and that would give you your mechanical advantage as well. Now I'm going to explain to you the longer version so you can see why that is the mechanical advantage. Now, if you take a look at the 2 kilogram object, it has the force of gravity pulling it down, and it has a perpendicular and parallel component, and it's going to be the angle theta that's translated up here. So if we wanted the angle, we can go ahead and find that. We can go ahead and say the inverse of sine is the opposite of the angle, which is the 3 meters divided by the 4.5. And that gives us an angle of 41.81 degrees. Now, if we wanted to find the amount of force that you need to apply to get something up the ramp, you're basically counteracting this parallel component over here, which I'll just call the x component. And what you can do is find this hypotenuse, which is just mg. That's mass times 9.8. And then you multiply it by the sine of the angle. And then you would get a force of 13.07 newtons. Now, what you're getting out of that is you only need to put in 13.07 newtons to lift something that weighs 19.6 newtons, because the mg, the 2 times 9.8, is 19.6 newtons. So if you're overcoming the 19.6 newtons, you are pushing with 13.07 to get up that ramp, but then in turn you're able to lift something up that's 19.6. So then if you did 19.6 divided by 13.07, you would get 1.5 as your mechanical advantage for your force output, which is basically the weight of the 2 kilogram block in newtons divided by the force input, which is this horizontal component of our triangle. So taking a look at all of these different machines, all of them just have a different strategy of how to analyze them and how to find your force output and your force input. In the end, you basically just take your force output divided by your force input, and then you get your mechanical advantage. So thank you for watching and listening.